Alright guys, our last type of rock is what we're going to be learning about for the next couple of minutes. That is called metamorphic rocks, and this is due to heating, not melting, pressure, and or chemical reaction. So if it does start to melt, then it'll start to become an igneous rock. So it's important to know that it's just heat, not enough to melt the rock, and of course pressure and maybe a chemical reaction here and there. And that's marble. Okay, how do the grain patterns of granite, igneous, and the gneiss, which is a metamorphic rock, compare? So look at this. This is granite, and then this one is gneiss. So if you look, this one has some planes or bands in it, and this one's just kind of randomly dispersed. So this happens deep within the crust, and some granite becomes gneiss because of all of that heat and pressure to make that change. So how do metamorphic rocks form? Heat, of course. It has to be 100 to 800 degrees Celsius. You need to write that down on the side of your paper, right next to due to heat, but not enough to melt the rock. Right over to the side, 100 to 800 degrees Celsius. And of course, pressure, and it's 100 or 1,000 times stronger than at the surface. It happens deep inside the earth. It changes the appearance, the texture, crystal structure, and mineral content. It can form from any other type of rock, including another metamorphic rock can change into another one, which is kind of cool. So how does metamorphism happen? 1, if rock is near magma. 2, if it's deep underground. And 3, where tectonic plates collide. We'll talk about this in upcoming units. Alright, so this is actually an igneous rock, and it actually heated up and was smushed down with pressure. So now you can see these lines. It's almost like a hamburger, and if you press down on it, then it's become all those different layers and things like that. Alright, this is also due to pressure. So this is in Labrador, Canada, some mountains in here, and you can actually see the metamorphic rocks on the side of the mountains because of it pressing down. And also it heating up inside of the mountains. So now it actually has these lines on the mountains instead of, just some random things going on. Alright, so this is actually what we're going to be looking at tomorrow, where granite changes into gneiss, shale into slate, and sandstone into quartzite. So as soon as that heat and pressure is applied, it'll change into a different rock. So these are called parent rocks up here, granite, shale, and sandstone. And then the metamorphic rock is gneiss, slate, or quartzite. There are 2 types of metamorphic rock. The first one is foliated, and the second one is non-foliated. Foliated is where grains are in parallel layers or bands. Your examples are slate, schist, and gneiss. And non-foliated is where their grains are arranged randomly, so you can't really see layers or anything like that. And your examples are marble from limestone and quartzite from sandstone. Alright, so think about this one down here. Which one would that be? Since we can see those lines, that would be foliated. Alright, and we're going to look at these tomorrow. A couple of these, actually 5 of these, so I will see you tomorrow. Hopefully you have your notes. Make sure everything is filled in, including the igneous and the sedimentary rock section, because we've already gone over those. The back of this sheet should not be filled in yet because we haven't gone over those. So have a great evening, and I will see you tomorrow.